Welcome to the start of Chapter 10. Chapter 10 will come, or Unit 10 will come in two parts. The first part is just two sections, today and tomorrow, and then we'll take a quick quiz on that, and then we'll get into part 2, and part 2 deals with some shortcuts pertaining to the first section. So we're going to be learning about a derivative. And so, first of all, before we do derivatives, it's important that we know the terminology that sets up for it and the little shortcut symbols that we're going to use to represent it. So a derivative is, by definition, the slope of a tangent line to a function. We'll get in that a little bit in more detail shortly, but when you find a derivative, you write it this way. This is a little bit hard to see on these sheets, but there's an F, sort of a dash, like an apostrophe up there. That's read F prime of x. Or if you're given y as your original function, like if you look down at the bottom, if you're given y, you would maybe write it as dy dx. And it's read just like that, dy dx. But that means the derivative of y, the function y, with respect to x. Both of these things here mean the same thing. These mean the first derivative. And the first derivative, like I said, is the slope of the tangent line of the function. So what we're going to do for our first portion of this unit is we're going to see where this formula that we're going to use derived, or where it came from, how it was derived, and then we're going to practice using it. But you'll find as we use it that it gets very complicated. And so what we're going to end up doing is going through some shortcuts that thankfully people figured out for us. So let's start with a little, where did this formula come from? Let's start defining some of these things. Now, this is not something, what I'm writing down right now is not something that you're going to have to memorize, be able to reproduce. You don't even have to write it down in your notes. Just sort of follow along because I want to show you where it came from. There are a couple things that we need to discuss before we get into this. And the first thing is the definition of a derivative deals with the term slope. And remember, slope is the pitch of the line between 2 points. It's the rise over the run between 2 given points. And you learned a formula for slope back in your algebra days that was y2 minus y1 over x2 minus x1. This may or may not look familiar to you. And again, this is not something that you're going to have to memorize. I just want to show you where the formula that we're going to be using came from. The other thing that I want to discuss is, what does it mean to be a tangent line? So this is an algebra topic, slope. Tangent is a geometry topic, and a tangent line, some of you may remember, is a line that crosses or hits. You probably talked about it specifically to circles, but it hits a circle at just one point. So this is a tangent line that we're looking at. It hits a circle at one point. Well, we're going to be doing a tangent line to a function. So we're going to be crossing a function, not necessarily a circle, at just one point. So in my picture, I want to sort of bring these two things together. I want to talk about the slope of a line and then put it so we can make it the slope of a tangent line. Because when we start with points, what we do is we start with points that are separated to find a slope. So if I'm trying to find the slope of the line that comes from connecting these 2 points, I need 2 points to work with. So my first one is x, f of x. And then my second point, I'm going to move that point down the road here h units over. And I purposefully picked h units over because it works well with our formula that we're going to be using. And so if this is h units to the right of x, then up here would be f of, oops, I should put it over here, f of x plus h, because that's how functions work. So this is the point x plus h comma f of x plus h. So what I did is I created 2 points on a function. One that is x f of x and the value of the function at x, and the other one that is h units down the road and the value of that point of the function h units down the road. Okay? And so if I were going to find the slope of this function, or slope of the line between these 2 functions, I would take y2 f of x plus h. So I'd call this x2, y2, x1, y1. I should have done it in order, but this is the first point, this is the second point. So I do y2 minus y1, f of x plus h minus f of x, over x2 minus x1, x plus h minus x. And if you look closely, the x's are going to cancel out. So what we end up having is f of x plus h minus f of x all over h. Now if you look back at the little bubble that I circled on the original page, and if you again need to pause to kind of get that down, you'll notice that that is the part of the formula that we're going to be using. It came directly from the slope, y2 minus y1 over x2 minus x1. So now, because we're talking about a tangent line, what we want to do is we want to squeeze these points really close together. So I'm trying to push the points as close as I can, and what I'm trying to make is is h as close to 0 as possible. And so I'm going to be pushing them together until they're sort of almost on top of each other, so that all of a sudden x plus h is right next to x, and I end up with these points so close to each other that I can draw a tangent line, a line that hits at one point. This would be my tangent line. And that tangent line happens when my 2 points are practically on top of each other. And that's where the limit part comes into play, because I'm forcing the h to be really, really near 0. And so the first derivative by definition, this is what we call the definition of the first derivative. The first derivative by definition is this formula. Again, this is not something that you have to memorize, but I just wanted to show you where it came from, and hopefully it makes sense. We obviously had to wait until we learned limits to do this formula so we can understand what that means. I am approaching the smallest number. I'm making h be as close to 0 as possible. Okay, so now let's jump in and use it. You might find this section to be very mathy. I've kind of used that term before, very mathy, where we're going to be doing a lot of algebra work. But my job is going to use the definition of the derivative to find the derivative of each function with respect to x. So I'm going to be finding either f prime of x, or again in this place I can do dy dx. So this function, and I can't stress this enough, the f prime of x and the dy dx, they mean the same thing. They're replaceable, so you could put dy dx always or f prime of x always. It doesn't really matter. It sort of just depends on how the original function was written. But typically what I do is, because my definition uses f of x, what I do is I rewrite each function as f of x. So this is f of x equals 3x plus 5. And then in order to use this formula, I also need x plus h. So I'm going to, remember when we find a function at a value, that just means I replace x with x plus h. And so this is 3 times x plus h plus 5. Or I can write it as 3x plus 3h plus 5. Okay, so f of x and f of x plus h. My first derivative says that I need to take f of x plus h, that's 3x plus 3h plus 5, I just figured that out here, minus f of x, that's a quantity, so I've got to keep it in parentheses, 3x plus 5, over h, and I want to do the limit as h approaches 0. And it's important that you put that in there. I sort of forgot it a little bit, but squeeze that in. It happens sometimes. Just remember to squeeze it in. The limit goes after the equal sign because the derivative is equal to the limit as h approaches 0, and now I need to clean this function up. Well, the easiest way to take a derivative is to just plug the value in, but when I plug 0 into this function, what happens is I'm going to have 3x plus 3 times 0, so that part's going to 0 out, plus 5, minus 3x minus 5, so the 3x's are going to cancel out, the 5's going to cancel out after I derive that, or bring that negative through, and I'm going to end up with 0 over 0. Well, that's a problem. We've seen this before. That's a red flag that shows up. Hey, something's wrong. I need to do something mathematically to clean this up. And so I am going to do some simplifying before I actually take my limit by plugging that in. So I will start by, like I said, distributing. I mentioned this before. I'm going to distribute that minus. So this is equal to the limit as h approaches 0 of 3x plus 3h plus 5 minus 3x minus 5 all over h. And then I'll do some math, clean this up, 3x minus 3x, 5 minus 5. I end up with the limit as h approaches 0 of 3h over h. Well, the h's are going to cancel out here. Oh, there goes my issue. That was my problem. And I'm going to end up with the limit as h approaches 0 of 3. Well, in our limits unit, we learned what if you have a limit that approaches a constant, then your limit is that constant. It remains that constant. And so my final answer here, f prime of x, or, because it started out as y, dy dx is equal to 3. That means the slope of my tangent line is equal to 3. So I did a lot of math there and a lot of work, and I know at first it seems a little overwhelming, so just sort of bear with me, work through it. This is much different than the last chapter we worked on, so just take your time. And if you have questions, as always, make sure you ask. Okay? So we found the first derivative using the definition. We're going to do it again with the next problem. So I'm going to rewrite this as f of x is negative 2x squared plus 4, and I need f of x plus h, which is negative 2, replace the x with x plus h, quantity squared, plus 4. And then what I like to do is I like to rewrite this by doing the simplifying or doing the distributing, in this case the x plus h times the x plus h, before I put it in the formula. So this becomes negative 2 times x plus h times x plus h plus 4, which is negative 2 times, I do this part first. You could distribute the negative 2 if you wanted to after you separate this, but you can't distribute the negative 2 before you break out the squared, so be careful with that. It's a little bit mathy problem that you have to watch out for. So this is x plus h, that's x squared, plus xh, plus xh, plus xh again, plus h squared, plus 4. Okay, so then this middle guy here becomes, move that over so you can see it, this equals negative 2 times x squared plus 2xh plus h squared plus 4. Distribute the negative 2 through, so this is negative 2x squared minus 4xh minus 2h squared plus 4. So now this is my f of x plus h portion. So this is part that I'm going to use in my formula, and this is my f of x portion. Now, it feels like I've already done a lot of work, and yeah, I get it. We have done a lot of work already, but we're not even done. All we've did is plug that in, and now we actually have to put it in the formula. So now I'm going to do f prime of x equals the limit as h approaches 0 of f of x plus h, that's this part, negative 2x squared minus 4xh minus 2h squared plus 4. minus f of x. So I'm going to subtract everything right away because I'm going to be minusing this whole thing. So when I minus this whole thing, it's going to be plus 2x squared minus 4 all over h. Now, if I take my limit right away, like I usually do, I can tell right now I'm going to have an issue with 0 in the bottom, and we're actually going to end up with 0 in the top. We're going to have 0 over 0, and so I know that I'm going to have to do some simplifying. So I might as well just do some cleanup right away. The 0 in the bottom is an issue. That should be an indicator to you right away that something's wrong, but I can cancel negative 2x squared plus 2x squared plus 4 minus 4. If you do this correctly, this should happen every time. You know you're on the right track. If you do this correctly, you should be able to cancel out everything on top that doesn't contain an h. So I'll be left with negative 4xh minus 2h squared over h. And what this allows me to do is cancel out the h. Just like we did in this last problem, I'm going to cancel out the h in every term. So h is gone, and then one of these h's is gone, so I can just get rid of that too. So now I'm left with the limit as h approaches 0 of negative 4x minus 2h. And now I'll take my limit by plugging 0 in. When I do that, f prime of x becomes, that's going to zero out this term, negative 4x. And so there is my final answer, the first derivative of this function. The slope of the tangent line of this function is negative 4x. Now, we didn't see it in the first one because it didn't have a variable in it, but you can see in this particular problem that my slope of my tangent line is going to change as my function changes. And hopefully that makes a little bit of sense. I'm not going to spend too much time on that, but hopefully it makes a little sense if you think about what this is. This is a parabola that opens down. So it's a parabola that opens downward. And if I draw a point or put a point on this function at any given spot, let's say I put a point right there on that function and I draw a tangent line, notice that my slope is positive. So the point right here would have a positive slope. But if I put a point here and draw a tangent line, the slope here is going to be closer to, it looks like almost 0. If I put a point over here and draw a tangent line, the slope becomes a negative slope. The line is dropping. And as I move through my x's, it's going to change where that, or what that derivative is. Where that derivative is, I should say. So again, hopefully that kind of makes a little bit of sense. I mean, as far as a new sort of topic comes. But right now, your goal is to be able to use this formula. And we'll go a little bit more in depth in that later on. But right now, be able to use the formula. That's what we want to do. Okay, so I'm going to flip over to the next side. And I will start by doing this next problem. Now, as they get a little bit more complicated, the problems, obviously, the slope is going to get a little bit bigger. So this one's already in f of x form. In order to do this derivative, I need f of x plus h. So that equals 4 times x plus h squared plus 2 times x plus h plus 5. I like to simplify this out before I put it into the definition of the derivative, before I do that where I set up for the limit so that I can cancel things out. This is 4 times x squared plus 2xh plus h squared. A lot of people forget this. They want to just say it's x squared plus h squared. So don't forget to do that. Don't forget to write that. This is x plus h times x plus h. And you have to distribute that through in order to get this value here. Then I'll distribute the 2 through 2x plus 2h plus 5. I'm going to distribute the 4 in front. 4x squared plus 8xh plus 4h. Oops, I put my parenthesis in the wrong spot there. That was weird. I don't know why I did that. But 4h squared plus 2x plus 2h plus 5. That's a big, long function. You'll be real excited or happy when we actually come up with the shortcuts, because as you can see here, this can get very complicated the more stuff. What if you had a cubed in here or a fourth power in here? That would be awful having to distribute that out. So we're just going to show you the definition on sort of easier functions, and then leave it up to you, or leave it up to the shortcuts later on to find the derivative of the more complicated functions. It's just nice, especially if you're calc bound, it's nice to see how, or be exposed to where that derivative definition came from. Okay, so we're going to put it into our formula. F prime of x is equal to the limit as h approaches 0 of f of x plus h, that's this bottom part here, so 4x squared plus 8xh plus 4h squared plus 2x plus 2h plus 5 minus this upper one, this original one. So I'm going to minus that all. So because I'm taking this whole thing and subtracting it, I'm going to change the signs of everything. So minus 4x squared minus 2x minus 5. Move that over. All over h. Now, I'd like you to go ahead at this point. We plugged it in. We went through how we plug it in. I'd like you to take a few moments and see if you can cancel some stuff off. Pause the video and see if you get to the next step. All right, so you should have crossed out the 4x squared minus 4x squared, the 2x minus 2x, the 5 minus 5, and you should be left with the limit as h approaches 0 of 8xh plus 4h squared plus 2h, everything cleaned up pretty nicely, all over h. Remember, your goal here is to be able to get rid of all of the h's in there, or get rid of the h particularly in the denominator, I should say. So an h should cancel out of everything, and we are left with the limit as h approaches 0 of 8x plus 4h plus 4h plus 2. You know you did it right if you were able to cancel an h out of everything and get the h out of the bottom. You know you did this right if every term left in the numerator has an h in it. So be on the lookout for that. If you're not able to do that, then you must have dropped a sign or missed something. So watch out for it. So now we have the limit as h approaches 0. That just means I plug 0 in for h. That's the most basic way to take a limit. And when I do that, this thing is going to zero out. And I will end up with my first derivative as 8x plus 2. All right, so my first derivative of that function is 8x plus 2. That means the slope of the tangent line to that function is 8x plus 2. So I want to go down to this bottom section, and I want to just kind of introduce you to how we're going to use this. And so if you look at the function that's given here, it is 4x squared plus 2x plus 5. That should look familiar. That was exactly the function that we had up here, 4x squared plus 2x plus 5. So instead of having to go through and do that whole derivative again, we don't have to. I know already that dy dx here is dy dx, the derivative of this function is 8x plus 2. We found it already. I'm just using the function that we did last time. So if I want to find the slope of the tangent line at a given point, well, that means I just replace, I'm interested in what the slope is when x is -1, so that I just replace x with -1. This is how we write it. Dy dx at x equals -1 is how that's written. And so this is equal to 8 times -1 plus 2, or -8 plus 2, which is -6. So if I were to graph this function, and if I think about what this is a parabola, okay? And if I were to graph this parabola At -1, I should find, I don't know exactly how, oops, it's probably up here more a little bit. At -1, I should have a slope that is -6. It should appear to be -6. That's what I'm looking for. If I graph the parabola at x equals -1, I should have a slope that is -6. If I was interested in the slope at +1, that would be over here, and it would be a different value. It would be 8 plus 10. And again, my picture isn't the greatest to show that, but hopefully you get the idea of what's going on. So what I'd like you to do is take the time to find the first derivative. Again, just pause for number 5 and find the first derivative for this next function. See how you do. And then come back when you think you have found it, and then we'll revisit it. If you did it correctly, take your time and go through that. If you did it correctly, your derivative should be 10x plus 2. If you did it all correctly, so I hope you paused it and actually went through that. 10x plus 2 would be your derivative. Now I want to find that first derivative at x equals 1. So dy dx at x equals 1 is equivalent to 10 times 1 plus 2, or 12. Again, we're using the formula to find these derivatives, and that's going to be your practice right now. It does seem a little bit intense, I think, but just give it some time. My recommendation, like I said, is make sure that you find f of x plus h. Do not forget to square it if it has to be squared. In some cases it will, in some cases it won't. Don't forget to distribute. You know you did it correctly if you only have h terms left in the numerator, and then you're able to cancel out the h's or some of the h's and take your limit, so you don't have the h in the denominator that's causing that 0. When you're done, you should be left with either some constant or some function of x. Again, if you're asked to actually find the slope, once you do your derivative, then you will plug that value in for x to get your slope. So again, I know this is a little bit of a different unit. It's very mathy, a lot of algebra involved. Please take your time, and as always, if you have any questions, just ask. Have a great day.